Okay, hey everyone. Can you hear me okay? Hello, hi. Awesome. Okay, here we are. We've made it. Okay, this chat's too fast for me to read. Welcome everyone to COMP1531. 11 a.m. Too many of you are complaining how tired you are. Don't want to hear it. The day's almost over. I can't hear you guys, but I can read. Yeah, let's really get into it. Thank you all for coming. There's about 200 of you here. I think there's about 600 and so people in the course, so we're going to work on that number. But once people figure out how awesome these lectures are, they'll all be coming. I'll give it a couple more minutes just because WebCMS can sometimes take a while for the email to go out to everyone. So I'll just catch up on some of the questions that you guys have asked. Everyone smash the notification bell. Why are there no in-person lectures and a stream at the same time? It's a good question. The answer is this is a large course with a large, there's 650 students in the course. If even half that amount of people, we couldn't fit in a lecture room with COVID distancing, right? So the lectures are all online and some of the tutorials are in person, some of the tutorials are online. Hopefully that answers your question. Any chance we'll talk about how to connect Git to VS Code? In the second half of this lecture is all about Git, and maybe we can address it then, although it's not really specifically in the scope because VS Code is not the only tool people will be using, but maybe we can explore it if we've got time. Okay, let's get straight into it. Now, there's a lot of moving parts to running an online lecture, as you can imagine. I've got YouTube, the stream, OBS, many moving parts. So if things go wrong, bear with me, let me know, I'm trying my best. But let's go to the keynote. Okay, now with the keynote, with all the keynotes, you can actually follow along yourself. So if you click that link I've just posted in the chat, you'll actually be able to get a live view of the slides. Hopefully you should be able to. And that's really cool because sometimes there's links in the slides and you can just click the links because you get, it's not a typical sort of slideshow. So let me know how that goes. If you click the link, you can open up in another tab and you can go back, you can go forward, and you've got the link afterwards. So that should be a really nice experience. And then it means you have all the notes that we've sort of written for you. The link works, fantastic. And hopefully when I go to the next slide in a moment, it'll move you too, which is really cool. All right. I must give credit to the previous lecturer, Hayden, who I'm sure you've all heard of. He wrote most of these slides in the previous offerings of the course. However, I've gone through and made some changes too. Okay. So let's take a moment to talk about what COMP1531 is all about and really what software engineering is all about. I'm really excited to teach this course. So I've been a software engineer in industry for many years. If you read my forum introductory post, and I hope you all posted some introductions to the forum as well, you would have seen that. Software engineering is more than just programming. Whoops. Here we go. It's not just programming. It's about taking programming skills and software engineering skills that you will learn in your degree and learning how to work on real projects in a team to solve problems. If you think of software engineering and if you think of the industry that you're all looking to roughly go into or adjacent to, you might not all be software engineers exactly, but it's all a collaborative effort. And learning to work with people, both the social aspects, but also the technical aspects. I mean, it's not that straightforward. How do you work on a code base at the same time with a team of people all around the world, all editing similar files and making sure that it builds and runs and compiles and solves problems, and there's not introduced any new bugs and problems like that. This is what this course is all about. So it's about understanding how software operates in large projects, having the skills to write and manage code with groups of people. That's really important. And to sort of, as our domain, as our context, we're talking about Python and web applications. But really, this is not a Python course, okay? We could swap the Python out for JavaScript. We could swap it out for C++. We could swap it out for anything. We don't really care about the learning outcomes of this course. While they include covering on Python, and it's good for you guys to get exposed to Python, this course is about the ancillary aspects of software engineering. Hopefully that makes sense. Now I've got to just get the live chat up on another window. So what is the core content if it's not just Python then? It's software engineering and the software development lifecycle, which we'll talk about. It's the how do we actually write code in teams? That's Git, which is one of the most important tools in the last 10, 15 years. And we're going to talk about that in the second half of the lecture. It's about project management. How do you make sure that you're on track? How do you make sure that your projects are going to be successful? One of the most interesting facts I've ever learned in my time as a software engineer is that 50% of software engineering projects fail. Doesn't matter if you're at IBM, it doesn't matter if you're at Google, it doesn't matter if you're a little software shop down the street. 50% of software projects fail. That's a huge number. Think of all the money lost. All the industries that have not made it through, all the projects that have not succeeded. And this course is hopefully to take you in, make you a graduate that makes that 50, maybe 52% pass, completing. Of course, we're going to cover Python. That's the language we're going to be mostly using. And you'll be making a backend to a HTTP web app, which is really, really exciting because that's how most modern applications are built. So you've all done COMP1531 or an equivalent at another university, hopefully. And this is a very different course. COMP1531 is your introduction to programming. It's very conceptual. What is selection? What is an if statement? What is a linked list? You're learning some basic concepts. This is now, how do we take the programming that we've learned and the new concepts in programming that you'll learn and apply it to solve real problems? That's what software engineering is. Software engineering is only a small amount of it is programming. COMP1531, learning to program by writing code to solve problems. Here's how do we solve this problem with an algorithm? How do we understand algorithms? How does memory work? COMP1531 is totally different. It's working in a team, a real team, to solve a real project and managing how that project works. So how's COMP1531 going to help you? It's a little bit small. Hopefully you can all read it. We obviously follow from 1511. And really any sort of software engineering or programming course that you take in the future, this is going to support you in. I don't know if we have 130 mechatronic friends exactly, but there'll be a bunch of you from mechatronics. I'm not throwing anything at 1511. It's one of my favorite courses to teach and to study, but I'm just trying to help everyone understand that this is not 1511 V2, right? This is a different course. Okay. Let me take a moment now to read through the chat. There is a huge amount of comments. And most of them aren't really too relevant. Okay, some language discussions, that's no problem. I don't know what that sound that just came through my speakers was, but that was weird. No shade. When we will meet this team? Good question, we'll talk about that soon. Okay, unless I've missed it, which is completely possible. Doesn't seem any super important questions that I've missed. Okay, so what do you need to know coming into this course? You should have done COMP1511. So we're assuming you have some good understanding of control structures. So, you know, how to write procedural code that you would have learned in C. Data types, memory, abstraction, the basic conceptuals, covered in an introductory programming course. If you've all passed COMP1531, I'm not worried. I'm just going to have a little sip of my coffee. What is a software engineer? We've sort of briefly covered this, but let's do it again. I think it's one of the most poorly understood maybe questions going around. And, I worked at Open Day previously this year, and all the high school students ask, what's the difference between computer science and software engineering? Well, at UNSW, there's a core-specific difference in terms of the course. You do an extra year in your software engineering degree, you're an accredited engineer, and you've got some engineering courses that you need to take. Do you need to be a software engineering student to be employed as a software engineer? Absolutely not. I worked as a software engineer for many years before I worked as a research engineer, and now I teach software engineering, and my bachelor was in computer science. So, this shouldn't be a surprise to anyone now. By definition, you're in your second year. But they are very similar courses. They're very similar fields. Most people that study, in my experience, that study a computer science course go on to enter the software engineering industry. Computer science as an industry is really either niche or it's academic. So here's the IEEE definition: the application of systematic, disciplined, quantifiable approach to development, operation, and maintenance of software. So notice it's not about coming up with a cutting-edge algorithm to solve this particular problem 5% faster or using 10 less cycles. It's about the whole end-to-end project. It's about delivering a project on time. It's about understanding the constraints of budget, personnel, working in teams, working with personalities. What is that tiny coffee? It's a espresso. Okay. So what happens in a world where we don't have good software engineering principles? So what happens in a world if we're all just computer scientists, let's say? Bad things happen. Projects get over-engineered. If anyone's heard the term over-engineering before, that's all about you're taking a problem that doesn't need to be as complicated as it is, trying to solve it with all this code and all this algorithms and these languages, and then you've realized you've spent more time writing a solution to the problem than you could have just solved the problem manually, let's say. It's about being predictable with terms of how much money is left, how much time is left, what skills do your staff have. One day in the future, all of you, as you progress through your careers, will be senior software engineers. You will have teams of software engineers under you. How do you support those people to deliver projects? That's what software engineering is all about. If you're following the link on the slides, you can click that bad things can happen link. And you can read about some of the... in fact, I think if I put this here... Can you see that? I think you might be able to. Yeah, cool. 11 of the most costly software errors in history. Let's look at one. $169 million in today's money. What happened? A rocket veered dangerously off course. They issued a self-destruct command. I didn't know they could even do that. 290 seconds after the course. The investigation revealed the cause to be a very simple software error. A hyphen was omitted in a line of code, which meant incorrect guidance signals were sent to the spacecraft. So software engineering isn't all about writing perfect code every time. It's about processes to catch times where people in your team or you yourself wrote erroneous code as well. And that's something we're going to cover a lot in this course. Someone's asked if they could get the links to the slides. Could someone repost the link for me? Sounds like me if I get a software job. But this is the point, Brandon. We all make mistakes as software engineers. I've pushed many lines of problematic code. But if you've got processes to test, to automatically test, end-to-end or unit testing to catch it, we can solve those problems. Okay. All right. Change of course now. Let's talk about the assessment of COMP1531. So in many ways, COMP1531 is about getting you to work on a project. It's about practicing good habits. It's not necessarily about learning new technical concepts. So the way we've gone about designing the assessment for this course is to align what we want you to do with your assessment so that you can get the most out of your course by putting the most effort. So we have the class mark at 20%. The class mark is comprised of a few aspects, but basically it's attendance at your tutorial and engagement at your tutorial, the weekly tutorial, and it's the completion of the weekly labs. So each week there's a number of labs, and I'll go through and bring them up in a second. And if you complete the requirements each week, you'll get the full tutorial and lab mark. Oh, you don't have permissions to post links. Okay, that makes a bit of sense. So now, tutorial attendance should make a lot of sense. The labs, what are they about? They're designed to get you to practice in an isolated environment. So let's say we're talking about Git, which is something that we're going to do in the second half of this lecture. The labs will have you practice some Git-related concepts so that you can get a really hands-on. Because the thing with the second aspect of the assessment, the project, is that there's a team of around 5 of you working on the project. So you may not all get to touch every aspect of the project. So the labs are to make sure that everyone gets involved with the really important concepts. Okay, project 45%, 3 iterations in a group of 5. Now I know I've read the forums, I've read the Discord, I snoop everywhere. Some people are worried and some people lament the project in this course. They say if you get a bad course, you're screwed. Only do COMP1531 if you can do it with friends. I've heard it all. Maybe in the past it was like that, a few years ago or something like that. But we really put a lot of effort into making sure this course is fair. We know it's an introductory course. We know it's a level 1 course, even though you're in your second year. We know it can be stressful finding a group, especially if you don't know people. We know sometimes people in your group won't have the same expectations and effort as you may want to have. We know that, we understand it, but we need you to work in groups to solve a project of this scale, right? So we have a number of mechanisms to make sure that you're okay if this happens. Number 1, we will individually scale grades within a project to reflect contribution. So if you're on your own in a project and you feel like you're carrying the weight of the project, and there's some evidence to demonstrate that, and we'll talk to you all about what that evidence is once we cover the Git concepts. Your mark will be lifted, and it will be as if you were in a group of 5 hardworking students. However, if you're in a group and you're not lifting any weight, your mark can individually get scaled down. We also have an amazing team of tutors that really care about the groups, the dynamics, and you personally. So if you speak to them and you explain your problems, they will speak to your group members and they will talk to me. We meet once a week. All the tutors get paid for it, and we discuss all the groups and we talk about what the problems are, how do we make sure it's fair, etc., etc. So I really just want to put at ease all your concerns about the group projects. They're designed to be really fun, and they're designed to be really realistic. I mean, I've never worked on a project in a group where there weren't issues with certain people. Not because they're bad or they're not trained well or anything like that, just because that's the nature of working with others. And then we have the exam, where 35%, and that's sort of covering some theory and some of the Python programming. And the idea of the exam is that if you've done the labs and you've contributed to the project, you'll have no problem with the exam. Let me just read the chat again and catch up. I haven't got a webcam, so if I can't open my webcam in my first tutorial, will my score be affected? So, good question. Tutorial 1, we're not taking attendance marks, just because there's a lot of, stuffing around people of finding which course, tutorial they're in, etc. So there's no tutorial marks in week 1. Onwards, we really want you to turn your webcam on. So if you really can't, or there's some environment where you don't feel comfortable doing that, all you need to do is speak to your tutor. I mean, I will say this over and over and over. Our tutors are the most amazing group of tutors I've ever worked with. They care about you. We're not against you. We're working with you. So if you just talk to your tutor and explain something, 90% of the time, you'll come to an arrangement that you'll be happy with. Okay. No crying yourself to sleep. Is there a hurdle in the exam? Do you mean, is the exam a hurdle? If so, I don't think the exam is a hurdle, no. But we'll talk about the exam a bit later in the course, but no, it's not a hurdle. It's a 3-hour final exam. It doesn't mean it'll take you 3 hours, but it's at home and you have a 3-hour window to sit it. Questions about enrollments. Okay. This is probably the most common question in the first few weeks. COMP1531, large course, a lot of different systems, and sometimes it takes some time for systems to catch up with each other. So if you get enrolled into the course, it might take it overnight or a day for you to get access to WebCMS, TicketLab, etc. If you think it's been if you just got into the course and you're not seeing everything, don't email me, maybe give it a day. If it's been a few days and you're still not getting access, then contact me. Or if you've already got access to the forum, you can post to the forum. Hopefully that answers your question. I answered the question about the exam. How do projects work if one or more members have provisions? I don't know what you mean by the word provisions, Luke. Have provisions. Yeah, I'm not sure. Maybe someone can clarify. When do labs get released? Okay, labs, I do apologize about this. I want all the labs to already be released. We're just making some tweaks to the labs. So week 1 labs are already released, as you would have seen. I've already seen submissions come through. And I'm working really, really hard to get the rest of the labs released as soon as possible. So I don't agree with like a rolling release of labs. They should all just be coming through as soon as they're ready. And they will get ready soon. Are there PDF versions of the slides? So, yes, at the end of the lecture, or before the lecture, I should actually do this. I just had some issues with slides this week. There will be a link to the PDF version of the slides, and they'll be on the WebCMS for the entire course. So at any point you can jump on and you can grab them and you can use them for your study notes or whatever you want to do. And then obviously the lectures will be recorded as well and you can go through and watch if you like. Labs are individual. Yes, they're individually completed and they're individually marked. Provisions are when you... I'm not too certain. Ability to delay deadlines by some time. So this is a good question. There are no extensions for the labs. Well, you could argue that there are extensions for the labs and that we've just already given you the maximum extension. So the reason we can't really do extensions on the weekly labs is because we release the solutions to you on a schedule. And if the solutions come out, we can't accept lab submissions, right? Because the solution's already out, defeats the purpose. If you get something like an ELS or you have a special considerations, you need a few weeks with some extensions, we have mechanisms to make sure that your mark isn't penalized. So we may look at your average lab mark and average it out for a few weeks where you can't do it. But like always, just work with us and we'll work with you and make sure you're okay. The labs are due the Monday after, I think, but each lab will tell you exactly when it's due. Okay, so I guess the question that was being asked was about if someone in your group has like an ELS or something like that. I mean, I can't really answer that. It'll be a case-by-case basis. You'll work with your tutor to make sure that it's fair and it works for everyone, is basically the answer. I'm not too sure if I answered that question correctly. Okay. Do we have to go to a lab to get them marked? Good question. I think it sort of depends on your tutor. You need to go to your lab to have your tutorial attendance marked off. And your tutor may find that if you're just not attending your labs, that they may stop going through your lab submissions on the marking sheet. But in theory, I would say that your labs will still be marked, but you won't be getting the full marks because you won't have your attendance that week for the class mark, if that makes sense. But I mean, you should go, the labs are mandatory, go to the tutorials and go to the labs. Are we expected to have finished week 1 labs by our lab day? No. So your week 1 labs are due next week, not this week. So you'll start working on your labs. I mean, some people have already started the labs, which is what is a good solution. But you should be working on the labs this week. Okay. If we can't attend our assigned tutorial one week, can we make it up by attending another tutorial? Yes, absolutely. You can contact me or another tutor and just be like, hey, I missed this. Can I attend your online tutorial? I will say though, do not rock up to other in-person tutorials because the COVID restrictions mean that we have limits on the amount of students in the room. So it's probably better to just attend an online tutorial. Okay? Okay. So that was the assessment. How are we going to teach you and support you? We have so many ways that we're trying to support you in this course. Obviously, we have the lectures, we have the lecture notes, we have the lecture recordings. We have the weekly tutorials and the weekly labs. In the tutorials, the tutor will run through activities with you that will directly support your lab or project progress. The labs are small activities designed to get you to complete and understand the relevant concepts for that week. The major project is where you really get to implement everything that we're talking about and practice working on a real project yourself. This is really going to support you not only for the course and your future courses, but in industry as well. We have the help sessions. So you should all have been given access to the Microsoft team for the entire course. There is a help session channel in the course. And the help sessions will be scheduled there. So you can just join the call. There'll be tutors in that call and you'll be able to get help. That's a drop-in service. So whenever those help sessions are running, you can just drop in and get access and get help. And then we have the exam, which is really there to solidify all the understanding. So there's 2 2-hour lectures a week. I'll work on getting the calendar sorted out. But the live link, the YouTube live link that you've used today, it's the same for every single lecture. I managed to figure that out, which is cool. So all you need to do is visit that URL when the lecture is scheduled and you'll be in the lecture. The slides for the lectures and the recordings uploaded will be available. Let me just have a drink. Okay, so fantastically, I don't even know if that's a word, this term, all the tutorials and labs fall after the lecture, which is really, really good. I mean, that almost never happens. We're really lucky. So some of you will have your tutorial and lab today. Some of you will have it in the next few days. Does everyone in this chat understand how to access their tutorial? So if you go to WebCMS and you go to tutorial timetable, you should get some information there. You should all be in a Microsoft team for your tutorial. Yeah, tiny mug, huge water bottle. You should all be in a team that'll either have a calendar made for your tutorial schedule if you're online. If you're in person, you should just see what the room is so you can access the room and find your way there. Tutorial and lab content. I mean, you know what? I should probably bring these up and show you. Hey. Okay, So Web CMS, lectures, tutorials, and labs. So you can just come here, find your tutorial code, find who your tutors are, and find, you should know if you're in an online tutorial or an in-person tutorial. If you're in person, you have the tutorial room, and then you have the lab room. So that's the first hour, that's the second hour. Okay? If you're online, you should already be given access to a team, and you just join the team call. I'm just going to give everyone a moment to see if they have access to this and everyone knows where they're going this week. Let me quickly read the chat. Is the password for Web CMS the same as your UNSW account? Absolutely. Yes. Okay, everyone seems pretty caught up with that. Okay, where do you find the lab and tutorial content? If you click this link, it will take you to the lab document, which explains when this lab is due, at what time, how many marks are awarded, the goals for the labs, the overview, and the actual labs themselves. Now let's actually talk about this for a moment. Each week with the labs, there's one of the changes we've made this term is to provide a bit more structure and guidance on which labs we feel like everyone should complete and which we feel like are optional. So if we look here, there are 2 mandatory activities for this week's lab. An introduction to Git and an introduction to Python. And then there's 2 marks, that 2 choice points worth of exercises you need to complete. So you can see that there's 3 activities here, all worth 1 point. So you can actually pick any 2 that you want to work on and complete to get your full marks for this week. Just to answer a few more questions in this admin heavy lecture. I have a tutorial in 1 hour and then another 2 hours for the lab. Should I attend both? Yes. Yes, please, absolutely. The first hour is the tutorial. The second hour is the lab that directly follows. But you need to attend the entire 3-hour session. It's just that you'll have to move rooms, but your whole tutorial will be moving rooms with you. So you'll just be going on a little pilgrimage. Okay. This week doesn't have tutorial attendance marks, but there's labs you need to complete, but this lab 1 is due in week 2. So you could argue there's no marks in week 1, right? Where should we do the labs? VLab, or can we use VS Code at home? You can do whatever you like. I use VS Code on my Mac desktop. Many students use VLab. I'm not an expert with the VLab, but your tutor probably is, so it's up to you. So something else worth mentioning, if you do all 3, so you get 3 out of 2, we will just cap it at 2. There's no bonus marks with the labs. The lab marking really is quite generous, so there's no bonus marks for that. You can't do 75% of all 3 to get full marks. You need to complete 2 of them. That's a funny question though. Do you need to clone the labs into a CC machine? Absolutely. We'll talk about that maybe in the second half of this lecture. You can do it in your own desktop. That's what I do. Yep, there's no MMR for the labs, although that would be an interesting way of marking a course. I got a page not found when I clicked the Git basic lab exercise. It might just be that you're not fully enrolled in GitLab yet. Maybe if other students can let me know if they're having a similar problem or not. Can I use VS Code and link it to VLab UNSW like I did in COMP1531? I don't imagine there'd be any differences with what you're able to do or not able to do with that. If we finish the lab early, can we leave our scheduled lab early? No, and I'll talk about why you can't in a moment. How can we submit our labs? We will cover that in the first tute lab. Your tutor will actually run you through how to submit lab 1 end to end. If you complete more points, you do not get extra marks. It gets capped at the 2 marks. The PDF links don't work on the lectures tab. I'll look into that, Grace. Thank you. Yeah, there might be a few links left that still link to the old course. So if you find anything like that, just let me know. Some questions about SSH keys. Again, I'll cover that a bit in lecture 2, and it will be covered a bit in your tutorial lab, tute lab. Yes, I'll talk about cloning in the second lecture. Okay. If I can't attend tutorials due to working 9 to 5, can I get attendance marks that way? Another way. Really, my answer would be to take a tute lab that falls after 5 p.m. So we have some that run up until 8 p.m. But you might need to email me if you're going to miss every single tute lab. Okay, some links obviously have fallen out of date, Jordan. I'll have a look at that. But if you just Google Microsoft install WSL, you'll get the Microsoft help page. It's just going off to the Microsoft page for that. Although I thought I did test that lab. Okay, anyway. Let's get back through the lecture slides. We've got 15 minutes left. Okay, the major project. So someone asked a question about why you can't just leave the lab after you finish that week's labs. And the reason is the major project. That 2-hour lab session isn't just a lab session where you work on the labs. It's also a session where you work and you meet with your groups and you meet with your tutor to discuss your group project. And in some weeks, you actually have the project demo where in that lab time, you present your iteration to your tutor. So you can't just leave the lab early. However, sometimes if your tutor comes to your lab first and you've done your labs, then potentially you could leave early. But that's what's happening in the lab. Groups are formed this week. So straight after this lecture at 1 o'clock, I'm taking all the 700 or so group preferences that have come through on the form, running it through a script to generate the group allocations and give those to your tutor. And so this week, from Tuesday onwards, you will be allocated into a group. Now, there will be a lot of movement with these groups. People will drop the course. People will enroll in the course. We have done this before. We know what they're doing. We know what we are doing. We will make sure you're in a group that's solid, probably from about week 2. There may be some changes between weeks 1 and 2, but don't worry about it. Let us handle it. Don't stress about it. The project will be released Friday evening of week 1. We get straight into it in this course. This isn't your first rodeo. Major project information will be posted here. That link, is it old? It might be back to TV. No, that is the correct link. Awesome. That's the page that the information will go to. I spoke about the help sessions. They're drop-in sessions on the Teams tutorial channel. Can we see the scripts that generate the group? Yeah, I think I can share that. Maybe at the end of this lecture if there's time. So help sessions start this week, Thursday and Friday this week. We have a couple of awesome tutors that have some help hour sessions. Not many hours. I think there's only about 4 hours over the 2 days. However, as we get into the course, the number of tutors and the number of hours on the help session will increase to deal with demand, right? But on Thursday and on Friday, you can see there's a schedule. Oh, it's actually taking you right to Teams. You'll see there's a Teams channel and you'll see a calendar on the Teams and you'll see the help sessions. If you don't have access to Teams, I'll be fixing that throughout the week. Pipelines I'll talk about in the second lecture. I did not see the form. Oh, it's unfortunate. The form was on an announcement on WebCMS over a week ago. And then I posted a reminder about it. Sorry about that though. Is it okay to collaborate with team members when doing labs? That's a great question. And it's a complicated question. I don't know if I've given the plagiarism, I haven't given the plagiarism talk to you guys yet, but I know you've heard it over and over and over. The labs are individual activities. However, working with people to solve problems that you're stuck on is a good skill. Working with people to solve a problem completely together and that you don't have an understanding of it is not good. I believe everyone knows where that line is between collaboration and collusion, let's say. I'm not going to spend hours and hours talking about the differences. The labs are individual. You can work together a little bit. You should be understanding everything that you're doing. Are we expected to be able to do week 1 labs really? Yeah, I really, absolutely, you should be able to do the week 1 labs already. There's some little things that you might be stuck with. That's normal, but conceptually, absolutely, you should be able to. There's no Moodle for this course, so we use WebCMS. And the Moodle should link to the WebCMS. I thought I set that up. If you don't know anyone in your lab, that's absolutely fine anyway, so you wouldn't have been able to do preferences anyway. Preferences have to be within the lab. Okay, final exam isn't scheduled yet. There's no hurdle requirement. There's no Mercy supplements. And details of the final exam, there's an exam link on WebCMS. The details will be released as they're available. Okay, what do you do when you're stuck? What do you do when you need to get help? Being a good student is all about identifying when you're stuck and getting unstuck as quickly as possible so you can make as much progress as possible. Talk to your project group members. These 5 people will become your friends. I know last term I taught this course. I was tutoring. I had a bunch of groups. I became friends with them. They became friends with each other. Use your group members. Use the Ed forum. Has everyone gone to Ed? So you should all, if you click the forum link in WebCMS, you should all have access to WebCMS. You can see there's a bunch of questions already. There's the big introduction thread. I have many tutors and myself that dedicate a lot of time to answering these questions. You can see these ones have just come through in the last few hours. Use the forum, but please do read the forum a little bit before posting a question. We get a lot of questions on the forum. We have a lot of good answers on the forum. It's much better for everyone if we all read it. So read the forum first, then post your question. Go to the help sessions, then email your tutors, and then finally, if neither of the previous 4 steps worked, you can email me at cs1531@cc.unsw.edu.au. The reason for this isn't some egotistical power trip where I'm the last resort. It's just that I don't scale as well as these previous... oops, I should probably go back here. I just don't scale as well as the previous steps. And the tutors don't scale as well as the help sessions, as the forum, as the team. And you're all invited to be my friend in this course. Absolutely, Brandon. Daniel, this is my first semester here. I straight up don't know the terminology. That's absolutely fine. There are so many people that want to help you. I want to help you. I'm new to UNSW too. I haven't even been here for a year. There's still many terms that I'm not familiar with. I'm not even familiar with the campus. I'm going to be lost all week. I'm actually going to come through and visit all the tutorial labs later today and for the rest of the week. I'm going to be lost as well. We can just be lost together. I can't give you until Friday for preferences. The preferences form is already closed. That's because I need to get the preferences generated before the tut labs so that we can put you into groups in week 1. So hope you understand there. A hurdle is, so some exams, so let's say you did perfectly in the course, you got full marks up until the exam, in the project and the weekly labs. You may already have a passing mark. You could not sit the exam and pass the course. If the exam was a hurdle, you would fail because you need to get at least 50% on the exam. That's what a hurdle assessment is. We don't do hurdle assessments for our exam. Download Lost on Campus. Yeah, I already got it on my phone. Good one. You can't view the groups yet because they're not made yet. In tutorial 1, later today or later this week, your tutor will make the groups on team channels. So you'll get that sorted soon. All right, I'm taking way too long. How do you actually get started with the course? I know a few of you are asking this. If you're using a CSC machine or you're using VLab, you're ready to go. Everything's already installed for you. If you're using Linux, all you have to do is install Git. Whatever flavor of Linux you've decided to use, you use whatever package manager that distribution uses and install Git. On Mac OS, that's what I use. You install Python, you install Git. I can't run through every different environment and how to do these things. But there's a bunch of different installations. We're going to talk about that in a second. On Windows, I 100% recommend you install Windows WSL. That's basically a Linux distribution environment within Windows. Then you install Git and Python just like you're working on Linux. Where to go? WebCMS, I've already shown you that. If you don't have access, don't worry. You'll either be given access very soon or you can email me and I'll make sure you get access. EdSTEM, that's where the forum is. And I'm going through this quite fast because you can just get these links later. GitLab, that's where all the labs and all the project all the project work is. Microsoft Teams, that's where your online tutorials are. That's where the help sessions are. And that's where you'll work with your group members. We use Git, we use Python, learn how to install them. We also use a system called Formative. And your tutors will run through this in the first tutorial as well. So you'll see in the lab exercises, each week, what we want you to do is you'll be given access to the Software Engineering Fundamentals course on Formative. Each week, there's a check-in lab, a check-in activity. All you have to do for this is submit one lab that you completed that week that you found particularly interesting or exciting or challenging, and your tutor will actually give you in-depth, formative, qualitative feedback on things like your code style, your thoughts, your misunderstandings. It's an opportunity to engage one-on-one with a software engineering tutor and to get some feedback on your lab. But you don't have to complete any extra labs to do this. All you do is pick one of the labs you already completed that you found particularly challenging and use this system to submit it. Now, it is worth marks. The bottom 2 links don't work. I'm really sorry about that. I'll fix them up and I'll show you. And all of this you'll run through in a much more intimate environment with your tutor anyway. So don't too worry about the links, but I will fix them. But I can also just show you. So if you go install Git, let's say Linux, well, you might have to say like Ubuntu, Atlassian generally have good guides. apt-get, that's obviously the way to do it. Oh, there you go. So there's a bunch of different links for all the different platforms here. This is a good point. I want to take a moment. This is quite important. This is what I was talking about, that COMP1511 is different to COMP1531. There are a lot of different systems. These are real industry tools that we're talking about. So what you'll notice is that the links change. Yes, we should maintain the links a bit better, but this course is all about how to learn to be a successful engineer. And that means learning how to find the current state of the industry, the solutions, and how to do things. So I apologize that sometimes the links don't work. Things change really quickly. Between T3 and T1, the links have changed, from the websites that we've linked to or the tools themselves. So it is worth just keeping in mind that when we're dealing with industry, this industry moves really fast. Concepts change really quickly. That's just the nature of the beast. Okay. Let's quickly talk about the software development lifecycle and how it pertains to you in this course. Design, development, testing, deployment, maintenance, and requirements and analysis. In this course, you will touch upon every single one of these activities. Step 1 is all about requirement analysis. Talking to your users, talking to your stakeholders. You can't see my slides. Talking to your users, talking to your stakeholders, analyzing the problem, determining if there is actually a problem, and determining what needs to happen both functionally and non-functionally. Generating diagrams and models to help plan out what you need to do. And it's arguably the most important part of software engineering, and we have many activities on this. Design. What do I actually need to build? So before anyone writes any code, what should this solution look like? That's the design. I'm going through this fast because, again, you can access this after. Development, that's sort of the most straightforward part in some ways, writing the actual code. This is not usually where the problems are. Most software engineering projects don't fail because something is not technically achieved. It's because the wrong thing was set out to be achieved. Testing, this is really important. You'll do a lot of this in this project. This is something that may be new to you. End-to-end testing and unit testing are two really important topics that we'll talk about. Deployment, how do you make your project available to its users? And maintenance, if a library gets updated, when do you update that library in your project? When do you not update it? How do you monitor for security issues? That's maintenance. So we will touch upon every single aspect of this in this course. I can't stress this enough. This is the most exciting course that I've ever taught. I think it's a really exciting course that you're going to learn. You're going to learn a lot of different things. What amazed me the first time I taught this course last term, coming from another university, is just how much you guys will build in this course. So yes, that means it takes a lot of time and it can be a lot of work. I understand that. We're here to support you. But once you've completed this course, and you all will, I can't tell you how many real skills and experiences you guys will take from this course that are so relevant in industry. What you build, the actual project itself, it's a real project. You will see, we give you a real project and a real front end that you can actually use. And you can see actually how do I build things that users can use and to solve real problems. You will learn so much. I'm really excited to teach you in this course. Here's a feedback QR code that you can scan. I know you've got lots and lots of questions about getting set up. We're going to talk a bit about that in the next hour. I'm going to give everyone a 5 to 10 minute break. Go make a coffee like mine. You can't see that, can you? Go make a coffee like mine. Get some water. Have a stretch. Please. Another thing in this course, we really care about your feedback. You all know how to use a QR code now since the pandemic. Scan the QR code. Let me know if that works. Give me some feedback on how this lecture went. This is an odd lecture because it's very admin heavy. There's lots of questions and I'm interrupting to answer the questions. It won't usually be like this in the other lectures. But in terms of the format and the experience, give me some feedback on the lecture. This QR code will be at the end of every single slide, so you can continue to update me on how you're going. But like everything, please be constructive in your feedback. It doesn't have to be, you don't have to stroke my ego and tell me my lectures are amazing. But, try not to be too cynical. Okay, we covered a lot. My mouth is quite dry. Let's see what the last few questions are. Again, in terms of installing all the tools, that's where your tutor and the help sessions and the forum will help you. I can't debug, 300 to 600 people's systems on a lecture. I hope you understand that. You enter every COVID sign link manually. That's a big effort. I mean, this is not a mug. It's a espresso cup. I don't know. It's from my grandparents. So I don't know where you can buy it. Okay, yes, you'll be using Python 3. We'll give you the exact version we need you to use in the labs. Is VS Code good enough for this course? Not only is VS Code good enough for this course, I've worked on projects from a vast range of projects. I only use Visual Studio Code for 99% of the code that I write. There is almost no other editor that I use anymore. I love VS Code. It's awesome. I don't like IDEs like Visual Studio. And I don't like editors to be too slimmed down either. VS Code is perfect for me. I use it. I'll be using it in the next lecture. I love VS Code. The major project, there's one project for the entire course and every group. It would be insane to have different projects. You'll see because of how complex the projects are in terms of like what we would need to do to make multiples. Second half of the lecture is all on Git. In terms of should you work natively, should you work on VLab? It's a good question. I would probably work natively. That's just me. I know Hayden, for example, still uses VLab for many things. But I like to have my development environment be native and local. But not everyone works like that. This message is sponsored by VS Code, absolutely. Python is the primary platform for street-side malicious payloads. Interesting. Notepad++ gang, they're all gone, Stephen. Is it better to use VS Code or VLab? That question, Theo, doesn't quite make sense. They're not similar tools. VS Code is a text editor. VLab is an entire machine, a virtual machine. So that inside it can have VS Code. The question is, should I work on VLab or should I work natively? And the answer is, well, it depends on your machine. Some people don't want to install all the tools natively and locally. Some people do. It's up to you. I use Nano. Good luck. That's all I say. Microsoft Word is the best IDE. Yeah, absolutely. Will we be able to get help setting up VS Code in labs because I'm struggling to set up Git and VS Code? I'm going to do a little bit that, Sienna, in the next lecture. But yes, you will get help in the labs. And then there's also the help sessions that you can get help. Has everyone scanned the code? I'm going to go to this screen now. Yeah, Vim is another tool that people use. There is a Vim plugin for VS Code. I've tried to learn it many times and then I run out of effort. Okay. Pen and paper, best IDE. Vim is too much effort. Yeah, I've wanted to learn it so many times and then I'm just too busy and I don't have the time to lose productivity for too long. Okay. So please feel free, guys. Go get some water. Go get a coffee. It's a carafe, actually. The TV, it's not that big. It's just probably the angle of the camera. It's hot. I need to go put the air conditioner on. Small mug, big water. I don't know why you're all calling it a mug. It's insane. Okay. Okay, here is the link to the next set of slides. don't need those. Tran, yes, all we learn is Python and Git and things like that. How do you distinguish different SSH keys for GitHub and GitLab? I'll talk a bit about the SSH keys shortly. What do I use to make my coffee? I have a espresso machine. Let me know if you want more specifics. What courses do you recommend for further software development? To be honest, Justin, I'm not the best person to ask for that. But we can discuss that sort of as we go. I've been trying to clone the repo for the first lab for like an hour. I'm about to cry. Yeah. Okay, Brandon. I'll try see what's going on. Yeah, the slides in a PDF version and the actual interactive slides will be uploaded to WebCMS. Yeah, I grind my own beans. I get... I only moved to Sydney in December, so I'm still trying to find an espresso bean delivery service that I like. But I've got a... Maybe one day I'll take a photo next time and show you. But yeah, I grind my own beans. I weigh my beans. You know, I have a dual boiler machine. Yeah, I like coffee. Is it true that you need data structures to be a good software developer? Absolutely. Absolutely. Yeah, I'm used to cloning with a personal access token. So am I, Felix. I'm more used to GitHub than GitLab. But I'll show you what to do. Yeah, so if you have a good espresso service, delivery service that's really good, let me know. I saw the Tea and Coffee Society at O Week. I should join. I do like tea as well, yeah. I just love caffeine, really. All right. It is 7 past. Let's see here. Oh, what have I done? That's not right. If you dislike tea and coffee, would I fail the course? Yes. Yeah, maybe I should go to that. Where have I worked? Good question. So I'm from Melbourne. I only moved to Sydney. Well, I've been working at UNSW since July last year, but I was working from Melbourne. So I worked as a software engineer in it's a complicated question. So I worked in a research lab that changed names a few times, but now they are known as the Applied Artificial Intelligence Institute in Melbourne. They're about 2 years old, but they existed sort of before that point. And I was a software engineer there for about 2 or 3 years, and then I was a research engineer for about a year as I finished my PhD, and now I'm here as a lecturer. So in terms of what I worked on, I know some people have been curious. At first, I worked on a number of internal tools, so bespoke software systems for managing our projects. We had a lot of different projects. And then towards the end, for the last year and a half or so, I worked on, I actually worked in defense science. So all my software engineering work was classified. So I can't talk about it. You're a VP of the tea and coffee? That's awesome. Okay, we'll have to talk later. Yeah, and I'm Italian, so that's where the coffee thing's coming from. But yeah, something I want to do as well is to have some informal chats, so that we're not talking like this in the lecture. Okay, let's get straight into it. Keynote, let's see. Can you all see the slide? No, you can't. Why not? That's not connected. Alrighty. Okay, Git. Git. I'm sure you've all heard the word Git. What the hell is Git? So first of all, Git is a software, it's a application. Git is a program written by Linus Torvalds, who wrote Linux. So interestingly, Linus, who you should all have heard of the name, Git is an insult in like British English, but I don't know why it's actually called Git. So Linus is working on one of the biggest software projects ever, the Linux kernel. And he starts to get a lot of momentum, and he starts to get a lot of people contributing to Linux, okay? Then he comes across a problem that the source control tools that were around at the time, he did not feel were working and scaling for the size of Linux. So Linus Torvalds, definitely not Linus Tech Tips, don't ever say that again. He pauses work on Linux, while others kept working on it. I think he probably worked on both at the same time, I don't know. While he's working on Linux, some of these crazy engineers are just able to do things like this. Not only to have one of the most successful projects of all time in terms of Linux, but to also then create Git is just insane to me. But he pauses work on Linux and creates a source control tool to solve some of the problems he felt he was having with how he was managing source control on the Linux kernel. So Git is an application used to allow large groups of software engineers to work on the same code base and to manage version control of the code files. It is a tool that can track changes to code files over time in a detailed and systematic way. And it allows multiple people to work on the same files or the same areas of projects and seamlessly integrate those changes and to retain the history of those changes. So if you think of something like Dropbox or OneDrive that you've used, they maintain a history of files and allow syncing between multiple sources. But they don't really work as well for complex line-by-line code file collaboration like Git does. So Git is a version control tool that allows people to work concurrently on the same code base. It's built for programmers, although different projects and solutions can use it, not just code. And like I said, before Git, there were other ways of solving source control, but Git is so wildly popular that you will never really see another solution used anymore. Everyone uses Git. Now, don't confuse, I've sort of gone ahead here. Let me talk about this and I'll go back. Don't confuse Git and GitLab or GitHub or Bitbucket. Git is Git. It is the application used to track projects and maintain the diffs between versions of the project that you write. The way Git works is that at some point you need a centralized location that stores the Git project. So your computer can store a Git project, and then a server can store a Git project. Now, you can have your own Git server. So some software houses, like maybe bigger ones like Google or something like that, I'm not too sure. I think Google do actually use their own, they don't use GitLab. They use GitHub for some external facing projects, but I'm almost certain that at Google, they have their own solution for how they store Git projects on the server. One day when we have some more time, we can talk about how Google manages their software projects using their monorepo. But that's besides the point. But for smaller companies, for me, for you, we're not going to really run our own Git server and maintain that. So we can use a existing Git service, such as GitLab or GitHub or Bitbucket. GitLab, interestingly, the one that we're all going to use in this course, the GitLab server is run on UNSW CSC servers. So we're not using GitLab.com or GitHub.com. GitLab is running on a server in Kensington, and that's where we can put copies of our projects so that if I throw my computer in the bin and get a new computer, I can clone that project and continue working. So these are all sort of competitors, if you will, GitHub, GitLab, and Bitbucket. For this course, we're going to be using GitLab. Git is interesting and different from other source control systems in that it's distributed. So if there's 3 of us working on a project, we all have a copy of the entire project and a copy of the history of the entire project, as does the server. And then I can push changes to a project and negotiate with the server how those changes need to be integrated into the source of truth, which may be on the server, and how that can be sent down to the other people working on it. But we're going to talk about this in more detail soon. So, okay, we need to learn Git. How are we going to do that? So at first, we're going to keep it really simple. We're going to make a simple project on a single machine, learn how to clone it, make changes, and push that. Learn how that works on multiple copies of a machine, and then learn how that works across multiple teams of people. Okay, so we're going to actually do a practical demo right now. But if you want a written guide, Atlassian's Git guide is probably quite good there. Okay. So setting up SSH keys and doing the Git clone. That's the first step. So why do we even need SSH keys? Does someone want to have a go at why do we even have this whole step? How is Git a language? I don't see that we said that. Maybe we did. Encryption, maybe. No password. Secure, maybe. Security, maybe. But why do we need it? Yeah, but so you're all correct. It's security, but it's also authentication. Some projects are private, and you only want certain people to have access to the code. So you need to authenticate who can access that code. And so we need some mechanism to allow your local version of Git to connect to the Git server. Different servers and different solutions use different ways of doing this. GitLab uses SSH keys. So SSH keys are kind of like a password for computer systems. All right, so I need to just rearrange some windows here so that you don't see the same thing over and over. Give me a second. I think this should work like this. What's this? We don't need that. I'll just put that there, I think. Okay, I'm just going to go here. That's not going to work. Okay, unfortunately that's cut off. Don't need that. In that case, let me do something like okay, that's what you can see there. Alrighty. That should be okay like that, I think. Alright. Okay, so first thing first. Yeah, you can all see this. Actually, let's just go to GitLab. When you go to gitlab.csc.unsw.edu.au and you're signed into GitLab now, I know some of you may not have access to GitLab yet. You'll be getting access soon. When you access GitLab, you will see a list of all the projects that you have access to. Now, I'm seeing many projects because I have access to all of your repositories. And a repository is the term for basically a project, a directory of code that's a Git project. But you will just see whatever you have access to. Okay. What I'm going to do here is create a new project. Okay, so the first thing actually, oops. Does this link work for me? No, because I'm not a student. Okay, I just don't want to show. I should have already had this loaded. Actually, you know what I should be able to do? If I just go home and just find a random student. Shout out if this is you. Okay, here's the first lab, and this is actually how you can get started with GitLab. The first thing you need to do is generate an SSH key and upload that key to GitLab so that the server knows that it's you that's trying to work on this code. Now, so the other thing I need to do is bring up my terminal. Okay. Let's swap that around for a sec. So here's my terminal. Now, if I ran this line here, so cat, which is to print out the RSA key at this location, what will happen is that my private key will be written out. Now, I don't want to do this because I don't want you to see my real private key. But if you have not created your private key yet, you need to generate one. And you can use this key in multiple different situations to prove that it's you. So just quickly, the way a private and public key works is that it's like if I give a server a public key, which you can think of as like a lock, and I know that I can have my private key, which is like my key to that lock, then I can prove that I have access to that system. So I can generate the lock, give the server the lock, and then use the key to unlock that lock, which is different from how a password works. But for what you guys need to do is actually to run this command, and you will generate a public-private key pair. Now, I don't want to save my key here because I've already got a key here. So I can actually just go, whoops. That should work. Actually, yeah, that should work. Okay. So I've said, okay, I want to make a key value, public-private key pair. I'm just going to make it in my desktop. Usually, though, for Linux-based systems and Mac-based systems, this is the location that you would have the key. You can enter a passphrase, or you can not have one. Excuse me. Okay, interesting. Maybe it wants the full path. Oh, enter the file, sorry. So this actually needs to be an actual file. So let me just go touch key.key on my desktop, run that. No password, no such file or directory. Oh, okay. No, that should be okay. What do the instructions say? Odd that it didn't like that. And also, let me just get the chat up as well. Okay. I might just use the real path there. Okay, I think it does want a directory. So make a directory called key. Drag that in. I think I might want the exact path. No passphrase. No such file or directory. It's really weird. That is really weird. I didn't even practice this because usually this is just not a problem. But maybe... You know what I'll do quickly? Okay, give me a sec, guys, everyone. Welcome to real world development. Okay, also something's wrong with my... Get that off. Copy that. Okay. Yep, so I'm going to use the default location because I just backed up my key basically, then you all quickly saw it. I want to override it, so I'm going to make a new key. So this is what you can all do. Yeah, don't share your private key. I'm going to have to change it. That's okay. Enter your passphrase. I don't want a passphrase. And then it created that key, public and private key at that location with the random art image. I don't know why they still generate that. That's like a sort of quick visualization of the key. Now, that means at this location, okay, we have the public and private key that we just generated. What you then do is go to this URL. Okay, now this is another case where the URL has recently changed because GitLab has been updated. But where you go to, so you go to GitLab. Yeah, I just wanted to change the path, Nathan. I didn't want to override my previous key, basically, but that's okay. I think you go to Preferences. Maybe make this a bit bigger. Yep. You go to, is it SSH keys, I think? Yep, here you go. And that's all right, it's not your bad, that's fine. And you paste in here the public key, the public key that you generated. Oops. So what you do then is cut out the key that you generated, which should be here. Now this is one that I've just generated that I don't actually use, and I'm hoping that you didn't see the full key on the stream previously. And then you just copy this, including the begin private key line, I'm pretty sure. I'm pretty sure that's what it's saying. Don't cut and paste. Oh yeah, don't paste the one above is what it's saying. Sorry, use your own. That's all it's saying. So you come here, you paste it here. You can give it a name, my lecture key. You can give it an expiry date, which is something that you probably should do. And you can add that key. Are you sure publicly visible private keys can compromise your system? So it's saying if other people know this key, then your system can be compromised. So I'm not going to add it because you all can see it, and I do use GitLab and all the marking and stuff is here. So I'm not going to add it, but you would add it. And if you did this all correctly, your Git system will use this public key and the server has the key, and they would be then able to prove that you are authorized to use and that you are who you are for that GitLab system. You can do this in the first lab, or you can try to do it now. GitLab wants your private key, not the public one. Okay. Oh, what did I copy? The RSA? Sorry, yeah, you copy the .pub. Sorry, yeah, you're right. Yeah, my bad. You copy the public key and put the public key into GitLab. The private keys should only be on your computer and should be kept private. Yeah, good catch, guys. Sorry about that. The instructions are here. Should I set a passphrase? I don't think you really need to, but you can. Okay, so what is this terminal? I think someone's asking. If you install WSL on Windows, you will get the bash terminal experience very, very similar to the one that I'm using. Yeah, don't wait for the tute lab. Do this. I mean, you could have done it right now, really. Blah, blah, blah. I can't find the SSH key section. I just clicked on my profile. I click on preferences and I click on SSH keys. These instructions are in the week 1 Git lab. So you will all have a repo called lab 1 Git basics on GitLab. If you don't yet, you might still be being enrolled, and then you'll be able to access these instructions. This computer can be on your computer or it can be on VLab. If you can't access the lab, it may just be that you haven't been given access to the lab yet on GitLab. So you might just have to wait a little bit longer, unfortunately. We don't manage all the enrollments into GitLab. That's done at the school level. Okay. All right. So now, if you're having specific issues, use the forum, use the help sessions, and use your tutorial and things like that. So if you've done that all correctly, yeah, the RSA is the private key. I don't exactly remember what it stands for. It's the format of the private key, and then the public key is the public key. So use the help sessions and things like that to get help. So now let's actually move on in terms of what we're trying to do here. So if I CD to my desktop, I can list all the things on my desktop, and here we are. Okay. What I'm actually going to do now is make a new project on GitLab. I'm going to call it lecture git test, let's call it. Or let's just call it lecture git. So you can all sort of do this. You can make a project yourself. And I'll show you how I clone this. So hopefully, if I run into any issues, we can run through that. So lecture git, I'm going to call it. I'm going to make it private. That's fine. Yeah, let's initialize it with a README file and let's create the project. Okay, so now I've created a Git repository on my GitLab. Yes, it's normal for it to have your computer name at the end of the key. That's how it knows what to call you. Okay. I've created this repository and I've said that I actually want you to create a file when I create this repository. What this means now is that I can clone it. Now, we set up an SSH key to authenticate who we were, so we will clone with SSH. So all I do is copy, so I just click to copy this SSH URL, okay? That's now on my clipboard. If I run git clone, so git, remember we said Git is just an application that can run on your computer, and it has a number of commands. The most fundamental of these commands is git clone. If I run git clone, it's not going to work, obviously, because it's telling us, well, you need to specify a repository for us to clone. So tell me what you want me to clone. And the word clone is really clear. It's saying take this repository and clone it onto my local system. Where is that repository? Well, it's at this SSH URL. And you can see there that that was all set up okay for me. So that just having my public key in my SSH profile was enough for my Git system to verify who I was using my private key. You can see here that it cloned the name of this project, lecture git, into a directory called lecture git. So if I type ls now to list all the files here, I don't know if everyone can read this well. You can see here that there's this lecture git directory that wasn't there before. If I cd into lecture git, you can see that there's that README file. If I open this project in Visual Studio Code, you can see, is that a bit too, no, that looks okay. You can see there's the README file, lecture git, and if you click the README file here, lecture git. This is the same file. It cloned all these files. Okay? Now, so that's git clone. The next thing that we can do is make a change locally, and learn how to give this server my local changes. So my change could be to update the README file. In this project, we will, not sure yet, but we'll do something. I save that file. Now, another thing I'm going to do is just use the local Visual Studio Code terminal, just so everything's on one screen. So I hit, I think, Control tilde to get this up. This is just another terminal, just like the one I was using. Okay, Brandon, don't drop the course because of a password issue. Go to your tutorial, go to your lab, post on the forum, and we'll help you out. Don't problem. Yeah, in worst case, just generate a new key and make sure you follow the instructions properly, and copy it up, hit save, and try again. If any one of the tutors is around and has seen this password issue a fair bit before, maybe you can jump in and let me know what's going on. If you solved the password issue yourself, maybe you could jump in. Yeah, make sure you include SSH RSA at the beginning of the key when copying and pasting it. Absolutely. Make sure you don't do what I do. Make sure you paste the public key and not the private key. Sean's trying to figure it out. That's awesome. Make sure you're copying. If you click clone, make sure you're copying clone with SSH. Because I don't think you should be getting asked for a password. Another thing you can do, yeah, make sure you put it in SSH keys, right? And not GPG keys or access. Yeah, no, it shouldn't have been access tokens. Make sure you did it on SSH keys is another thing. The clone with HTML seems to work fine. Okay. But that might be because you made a public repo and then it's not authenticating you at all. So you can only really test this if you used a private repo. I've half solved it. Add GitLab to your SSH config and then replace the URL in the clone command with the alias you've created. What are you saying we did to Ben and Justin? Sorry? You did all these things I'm saying? Yeah, it won't be the password that you used to generate the key. Look, let me continue. And we'll sort out what's going on with this. Maybe we'll jump on a call with someone after the lecture and see what's going on. Okay. And Sean's also looking into it, which is awesome. In terms of the email to configure Git, you can use whatever email you like, but use your UNSW one so it's easier for us to learn, who's doing what. Okay. So I've made a change to this README file. Let's just start with this. And I need to get that change committed and pushed to this repository so that this change here reflects this file here, which obviously does not have that change at the moment. So it's not as seamless as something like Dropbox. We need to be more explicit. So the first thing we need to do, well, we don't need to do this, but it helps, is to run git status. So git status is like, tell me everything that's happened in this Git repository between my previous commit. And you can see here it says, your branch is up to date with main. However, there are some changes that are not staged. What does that mean? Well, it's telling you, I modified the file readme.md, but it's not staged. What does staged mean? Staged means that a group of changes that I've made are ready to be pushed. Or ready to be committed and then ready to be pushed. So I can actually, The reason for this is we'll talk about further on in the course. The reason is that I can pick and choose which changes I want to stage at the same time. But to get through this at the moment, I can use git add, and I add the file that I want to change, that I want to stage. So I want to add my changes to the README file. And now if I run git status, you can see that I have some changes that are staged and ready to be committed. Now, the reason for this is that I can make further changes and then also stage those changes. But once I'm at a point where I'm ready to make a set of changes and push into my repo, I need to make a commit. Now, so I use git commit, okay? And every commit needs to be accompanied by a git message. This is really important. So -m signifies, and hopefully you can read this okay. I just made that a bit bigger. -m signifies the string that follows is my commit message. And I'm going to commit with the message, add some changes to readme.md. Whoops. And hit enter. Okay. If I run git status again, git status is your friend. We can actually see here, I'm on the branch main, and your branch is ahead of origin main, which is what this is referring to, by one commit, which makes sense. Let me try do something here. How are we going for time? 15 more minutes. Is it 12:42? Yeah, I think that's this one. Hopefully you can see this okay. So basically how Git works is that repositories are a sequence of commits. So, whoops. Origin is the default name for the repository on a server. So in this case, origin is GitLab. I can actually type git, I think remote -v. Yep. It's a little hard to see there. Okay. Git remote -v. I don't actually know why the flag is V, but what this does is list my remotes. And we're not really going to talk about remotes too much, but you can see origin is that Git repo on that GitLab CSC UNSW edu au server, right? That is the location of this project. So when I'm working with origin main, that means it's the main branch of the origin repo. And we'll talk about branches later as well. But so origin repo had a project with one commit. That included, the default README file. I then cloned the project, and I get the exact copy of that commit. I then made a new commit with my changes, where I added this line, right? But the origin, the server, does not have those changes. It does not have this new commit. What I need to do now is push back those changes to the server. Okay? How do we do that? Okay, we use git push. By default, git push will always use origin, I believe, but we can specify it. Git push origin. Okay, what just happened here? It compressed some of the changes, that's fine, that's just for the network, and it pushed my main branch locally to the main branch on origin, is what it's saying. So what I did was I told my origin server, my origin remote, hey, I have a sequence of commits that were ahead of yours. So basically it's saying, take this and transplant it and apply the changes so that you become now up to date as well. How do we verify that this worked? We go to this README file and we refresh it, and we will see the changes that we made. Yeah, my keyboard is, yeah, it's nice. What I did here was I caught up my server, my GitLab server, with the commits that I made. If I had multiple commits, it would have applied multiple commits. This is really exciting. We've now got a server with our commit history. Yeah, so this will be, well, it's included in the lecture recording. There are hundreds of websites that will take you through how this works. They will have some really good diagrams. There are YouTube videos. I'll show you the keyboard at the end of the lecture. So don't worry about resources, and we'll link to some. And you've got the help sessions, and you've got the forum, and you've got your tutor. You will get through this, I promise. Look, Git took me, a few years of using it constantly to really lose some of the anxieties I had around it and to become confident with it. Maybe not 2 years, that's quite long. By the end of this course, you will be at least relatively confident with Git. Git is very confusing. I'm not telling you all this and expecting you to just automatically get it. These are complicated systems and concepts used in industry. We're not, this is a real industry tool. It's not an educational system like we usually use in like COMP1531 or something like that, where we're teaching you the concepts. This is a real tool. It's challenging to get familiar with, and we're only scratching the surface, and I only know the surface of Git. Really, there are some crazy things that people do with Git. So all I'm trying to say is do not stress. It's normal to be overwhelmed by Git. It's a whole universe within software engineering, but it's really, really, really important. Okay. You're talking about keyboards. We'll talk about that later. All right, what's next? Okay, yeah, of course. Let's talk about the Git log. Remember I said, if you look at my whiteboard, remember I said that there's these two commits in the chain, right? There's the initial commit, and then there's the commit with my changes. If I run git log, I can actually see those commits. There's the initial commit, and that's the ID of the commit. There's the second commit I made, and there's the description. I made some changes to README. As more commits are made to a project, these will show up in the log. As multiple people work on the project, you can see it knew that it was me, Jake Ronzella, that made this commit. Now, you will need to set up your name and email so that Git knows who you are, and there's instructions in Lab 1 for how to do that. It's just git config. And then you can pass, you can have local or global git configs, and then you can pass how to add the username and email and stuff like that. That's all in the Lab 1, I think. Okay. What do we want to talk about next? We're done add, we did diff, we did commit, and we did push. Awesome. Next is multiple machines. So git pull and merge conflicts. We've only got 10 minutes. Okay. How am I going to do this? I know... So what would be really cool is that if I had someone else that could make changes to this project. I'm just trying to think if I can simulate this myself very easily. I think what Hayden used to do was also use VLab, but I don't really have VLab at the moment. So what I might do for this, because we're running out of time anyway, is I might record a video with another tutor, and we will have the multiple machines working on the same repository, make multiple changes, and then deal with the merge conflicts ourselves. I think that's a much better solution than what I can just hack together. Let me put the slides back on. And let me catch up with the chat. Um, okay, more keyboard chat. I gave up with the password thing. We will figure out what's going on with the password thing. There were some upgrades to GitLab, maybe something changed. We will investigate, don't worry. I just want you to follow on the concepts of what I'm talking about. If you do SSH, blah, 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 it shows that the key is sent, but the server doesn't accept it. Okay. Yeah, the problem is, I would go back to it. The problem is I can't replicate the issue. I did not have to put in a password. That's why I can't help you right now. So you'll get help after this. Yeah, you can't do it. Yeah, you understand the concepts. That's what's important at the moment. I know Sean's looking into it. We're looking into it. I'm sure that we post on the forum about it. We'll figure out what's going on and we'll update the instructions in Lab 1 so that it will actually work. And I might jump on a call with some people after the lecture to figure out what is going on. Okay? But don't worry about it for right now. Right now, we're just talking about these concepts here. Okay. Yeah, I do apologize, guys, but this is the reality of engineering. Okay. All right. Let me move my face out of the way. Git command summary. So something that's really good is to have a cheat sheet of Git commands nearby. This is something I do personally. I actually used to print out a Git cheat sheet and laminate it and just keep it on my desk when I was learning. So, these are the really common commands that you should learn in the next week or so. So cloning, we spoke about that. Status, those examples are wrong, I think, but status, log, git add, which is adding changes that you've just made locally to be ready for a commit. Commit, take a snapshot of all your changes and give it a message. Diff shows the differences between your current untracked changes and your previous commits. Git push your changes up and try and negotiate with the server how to add your commits to its chain. And pull pulls down those commits. So that can be actually how I finish off the lecture. Let's go here. Let's go to the desktop. Let's go to the GitLab repository. Now let's actually make another change here. In this project, we will write a Wordle app. So I've made my decision. Now I can actually make a commit on the server itself. This would just be as if someone else pushed changes to the server. So now I've made a new commit on the server. So if I view the history here, you will see there's actually 3 commits in the history. That makes total sense, right? There was the initial commit that was made on the server. There were changes that I made locally. And there were the updates to the README file that I made on the server. But I don't have those changes locally. Can anyone, looking back especially at that cheat sheet, can anyone think how I can sync my repository locally with the server? So, Sakif, you got it right, but I mean, yeah, it's weird because I don't know your names. Starkiller. Is it git push again? Let's think about A, the terminology, and B, what's happening. Git push pushes my local history to a server, and it's a one-way communication. Git pull is the opposite. Git pull is to say, what's on the server, I want to bring it down locally. So it is git pull. I run git, let's clear that. Git pull, origin. So I want you to use the server at the GitLab CC server. And you can see it realized there was a change to the README file and it made that change. And I had that change sync up in my editor. If I run git log here, you can see I have the 3 commits in the history And I've again synced up with the server. Now, there was a question, a really good question. Where was it? Who asked it? It was, where does it go? Justin. Okay. Does that mean if we want to add something, we always need to run commit and push? Add, commit, and push. Absolutely. It's a 3-stage process. I need to tell Git. Now, the reason for this will be a bit more clear once we have actual code files that we're committing. Each commit, okay, if we look at the whiteboard, each commit in history, in good practices, is this syncing? Yep. Each one of these commits is a snapshot, okay? I'm going to try to draw a camera here. Cool, that worked. Each commit is a snapshot. What does that mean in theory? Now, it doesn't have to be. This is just what we should be doing as software engineers. What that means is, if you've got a project with some Python code or some C++ code from COMP1531, each commit should be a step towards the final solution that you want to build. What that means is each step, each commit should compile and should run. It shouldn't introduce it might introduce new bugs because you're working on something, but it should at least compile, right? But what that means is multiple code files might need to change within a single commit. Does that make sense? Let's think about it from comp1511. You've got a .h file and a .c file, right? If you want to update a program, both of these files need to change. I would need to add the changes to program.h and the changes to the file.c and file.h. I wouldn't really want to commit the .h here and the .c here, because then if I jumped back to this commit, and we're going to talk about moving around the Git history in the future, if I change back to this commit before the header files change, but after the C files change, my code won't compile properly because it's not going to be synced up. So that's why we need to add all the different components we need to get to something that's committable. Then we run git commit, which creates the snapshot. Then we push the commit, and we can push multiple commits. So Hamish says, whenever you change a file, you add that file, then once all the changes are made, you commit those changes. Yeah, absolutely. Yep. Your name is Zach. Nice to meet you, Zach. Does git pull overwrite the local file? That's an interesting question that we can actually do it. Let's change the file. Let's make a Scrabble app. Let's actually commit it. I'm gonna quickly add git add readme. So I've added it. I check my status, it's added. I git commit change readme to Scrabble. Now I've made a commit. I've got now 4 commits here. Now I'm not going to push it. On the server, I'm going to change it again. What's another game? I don't know, Sudoku. I'm going to commit that. This is really interesting and something that you're going to come across a lot. My local commit history is now out of sync with the servers. So what happens if I push? Guys, take a guess. What's going to happen when I run push? While you guys are answering, Naroda, is a commit basically just one version of the file? No, it's a snapshot of your entire project. It's going to be an error, it's going to be denied, it's going to be an error. I run git push, there's an error. It was not able to push my changes to the server. Why not? Because the remote server contains work that I do not have locally. That makes total sense. I did not see this Sudoku change. It came from somewhere else. This is usually caused by another repository pushing. So someone in the chat, Zach Starkiller, pushed Sudoku to this file, but I never pulled it. And it actually gives me a hint here. You first want to integrate the remote changes before pushing. So it's telling me you actually want to run git pull before pushing. So if I do git pull, okay, this is even further more interesting. You have a divergent branch and need to specify how to reconcile them. This is actually something that's new to Git in the past year, that they by default don't tell you how you should merge your changes. And we do not have the time to sort of go into this, but there's two main ways, fast forward, a merge or a rebase. I'm not familiar with fast forward changes, but these two are generally the way to do it. So you can actually set how you should be doing your merges. But basically, what rebase does is we'll try and take whichever, so there's basically what's happened is, and I know we're going over time, so I apologize, but it's all recorded. Basically what's happened is, oops. Let me just move that up. There's been a commit chain that matched up. This made a change. I don't know if you can see that very well. This made a change in red. And this made a change, a different change. They're different. These are now divergent. Oops. I can't draw for some reason. Okay, I don't know what's going on. What did I just do? I've lost it. Okay, these are now divergent. I need to tell it a way to merge it in. So let's just do this method. Actually, what I'll do is git pull origin. I think if I do merge, will that work? No. I gotta just quickly look. Now they may have changed it, so I might just have to set my config to always do merge. Let's just do that. I run git pull. Okay, this is what we really wanted to talk about. Basically, it's telling me, so Git is an amazing system. Okay, yeah, no rebase. Yeah, Hamish, you're right. Yeah, thank you. Git is an amazing system. It will always try and figure out how to merge changes across different sections of code. However, if the change is on the exact same line and it happened at the exact same time from the same point in history, right? So it doesn't know that it went from Wordle to Scrabble to Sudoku, because it went from Wordle to Scrabble and to Sudoku at the same point in history. Git basically says, hey Jake, or hey whoever you are, I do not know how to resolve this conflict. It was made at the same time on the same line. I just can't do it. I'm a program. I'm not a human. I don't know what to do. You need to tell me what you want me to do. And it actually marks up the file with this weird syntax. Now, Visual Studio Code is doing some highlighting here, but it's actually added some characters. I can actually just cut out readme. It's actually added these signifiers here, and it's basically said like, hey, this is what's local, and this is what's on the server. You need to tell me what you want. Well, how do I do that? All I actually do is just delete the parts that I don't want, and I need to delete those signifiers. So if I decide, okay, no, this is actually meant to say Scrabble, that's the latest changes. I fix up the file, removing those lines. So now it says Sudoku. And then what I need to do, if I run git status, is I need to add and commit these changes and then push it. So I add the README file that I've resolved the conflict. I commit. And I can call it, switch back to Sudoku. And I can push. And there's no error here because in my Git log, I have a entire chain of commits that satisfies the server and my repo with how to resolve what happened. We had the initial commit, we had the initial changes and update. We changed it to Scrabble locally. We changed it to admin on the server, right? You can even see here that this is my server email, this is my local email. These changes happened at the same point. I then have a new commit that switched it back to Sudoku and included the previous change from the server in the chain. If I come over here and I refresh, we have the Sudoku app, we show history, we have the history, we resolved the merge conflict. This is what often happens when multiple people work on the same section of code at the same time. Now let me catch up on the chat. And that's the end of the Git lecture. I know Git is a complicated beast. You will get used to it, I promise. Let's see here. Okay. It wants you to resolve it locally first. Absolutely, Ricardo. Now, we don't need to add a branch to fix it. We'll talk about branches in the future. Yeah, fast forward doesn't. Yeah, that's why no one uses. Why you don't use fast forward for that. That makes sense. I'll talk about. We're not going to talk about the differences between rebase and commit based merging at the moment. What if someone makes a change after two divergent branches form? Does it save to both? Okay, let me read that again. What if someone makes a change after two divergent? Do you mean the two divergent branches come back and get resolved? If that's what you mean, I can answer that. Pipeline failed. We'll talk about the pipeline stuff another time. Don't worry about that, Ray. Okay, Git is not a programming language. Git is a program. I'm running the Git program. And that's how I'm communicating and creating these repositories. It's not a programming language, though. Do we need to use Git commands for labs? Absolutely. So Git is actually how you will submit your weekly labs. Can no one else make changes until divergent branches are resolved? So the thing you've got to remember, Scooby Snack is what I'll call you, is that a Git is a distributed system. So you could have 5 people working on a Git on the same Git repository. When you clone it, you clone the entire Git history of that particular project. So it's possible to have 5 divergent branches. What matters is how you resolve that, where you resolve it, and how that gets pushed to somewhere centralized, like the GitLab server. So I don't know if that really answers your question. You can continue to make changes, basically. You can get divergent for years. But at some point, if you want to have a centralized copy, you will need to merge in all of those conflicting changes at one moment, so that you have a history that makes sense and that you can continue to work from. Anaconda is horrible. That's what I don't like about Python. Well, we don't use Anaconda in this course, Felix. Okay, do I have... Yes, I do. Okay. So I know we ran 9 minutes over time. Sorry about that. I know Git is crazy. I know a lot of you are having issues with the password and things. We're going to get that solved. Don't worry about it. I would appreciate any feedback you have. Otherwise, thank you for coming to the first lecture. The next lecture is tomorrow at 2 p.m. I'm really excited for this course. I hope you're really excited. You're going to learn a lot. Trust me, in a few weeks, you're going to be using Git like an expert, and it's going to be awesome. Okay, Hamish is on top of the password situation. That's fantastic. I'll spend some attention on it as well. I'm sure there'll be some forum posts. We'll figure out what's happening. There was an upgrade to the GitLab CSC server a couple days ago. It's possible that some setting has changed or something like that we're not aware of. And I'm sorry I wasn't able to fix it during the lecture because I wasn't being able to reproduce that change. But welcome to software engineering. Nothing ever goes seamlessly. This is normal. You have to embrace this uncertainty to some degree. It's really exciting. I'm really excited. I hope you're really excited. You've got your tutorial and labs coming up today, tomorrow, and Friday and Thursday. It's really exciting. I'm looking forward to working with all of you. Have a lovely day. And, oh yeah, I'll quickly show you my keyboard. So it's a GMMK Pro with Gatoron. Oh, it's really blurry. With Gatoron black ink switches. Thanks, Hamish. Where did you post it? I'm guessing the forum. It was my COVID lockdown project. Yeah, I built it. Yeah. I lubed all the switches. I did it all. And then I've got the Rama keycaps that they dropped coming in like 6 months when they finally release them as well. Okay. All right, Hamish, let's see what you've done. Okay, let's all see if Hamish's solution works for you guys. There's the link to it. Add the following to SSH config or create the file if it doesn't exist. Okay, so it's some way that it needs to resolve the host server. That's interesting. All right, otherwise, thank you all so much. There's going to be a lot of communications and a lot of work coming up over the next week, so I'm looking forward to it. Have a lovely day, everyone.